Good morning. Let's work on a little Symbolab today. Today we'll do a little bit of pre-algebra. Let's reduce some fractions. Let's reduce the fraction 4/8. So we're going to solve instead of long division. If we do reduce the fraction 4/8, it will become 1/2. Let's see how we got there. So first we find the common factor of 4 and 8 in order to cancel it out. Okay, what two common factors do they have in common? Common divisor of 4 and 8 is 4. We factor out 4 from the numerator and the denominator because we have 4 divided by 4 is 1, and 4 goes into 8 2 times because 4 times 1 is 4, and 4 times 2 is 8. So that's how we get 1/2. All right. After doing so many fractions, you start to see these numbers that are in common with one another. They have the common factors, and you'll be able to simplify really fast. You just have to get used to it. The more of these you simplify, the faster you get. Because the 4 on the top, if you notice, what two numbers can you multiply to get 4? 2, okay? Well, 2 go into 8, okay? Well, 2 is small because if you were to divide these by 2, you would have 4 divided by 2 would be 2, 8 divided by 2 would be 4, so then you would have 2/4. So then you can still reduce at that point. Okay, you reduce by 2 a second time. 2 divided by 2 will give you 1, and then 4 divided by 2 will give you 2, and so it's still 1/2. You just have to make sure you're reducing as far as you can. Let's try a few more. 15ths. Okay, we hit go. So if we reduce this fraction, we're going to solve instead long division 10/15 and reduce the fraction 10/15 to make it equal 2/3. Now how do we get that? Let's go through the steps. Always find the common factor of 10 and 15 in order to cancel it out. Greatest common divisor of 10 and 15 is 5. So let's show those steps. How do we get 5, you might ask? The greatest common divisor, or GCD, of A, B is the largest positive number that divides both A and B without the remainder. Prime factorization of 10 gives us 2 times 5. You remember how to factor tree? That's another way to find your factors. Prime factorization of 15 is 3 times 5. And so 10 is divisible by 2 and equal to 5 times 2. Therefore, 2 times 5 are all prime numbers. Therefore, no further factorization is possible. You're looking for a prime number. That's why they call it prime factorization. Same thing with 3 times 5. 15 is divisible by 3 and equal to 5 times 3. Therefore, it equals 3 times 5. 3 and 5 are all prime numbers. Therefore, no further factorization is possible. The prime factors of 10, 15 are 5 times 2 and 5 times 3. And so the common factor, because the 5 cancels out when we set this fraction up, we have 2/3. If you have any questions, remember, always comment in the comment box below, and I will get to you ASAP. Let's try a few more. So let's say we have a different fraction here. Instead of 10/15, how about something a little more difficult? What if we had 73 and say we had 73 in the numerator and 102 in the denominator? Can we reduce this fraction? Well, the bigger the numbers you get, the more confused you'll be, and you'll ask yourself, well, how do I know this? This is a number I've never really multiplied. I need a calculator. Let's look. Solving the fraction and reducing 7/300 seconds or 102s. Solve instead of long division 7/302s or 100 seconds. Reduce the fraction. Steps. Find the factor from 73 and 102 in order to cancel it out. Common divisor of 73 and 102 is 1. When we see that 1, that means there is no other factor. It's just a 1, which is the number itself. And so therefore we can't reduce this number. Even though the definition says GCD, A and B, is largest positive number that divides both A and B without a remainder. That's exactly correct. Prime factorization, we would simply have 73 times 1 equals 73. What other number do you know that will go into 73? None. So therefore it's not able to be reduced. What about 99 over 999? Don't get confused by the consecutive numbers. Let's reduce this. So 99 can be divided, and so can 999 can be divided. Let's find the common factor. GCD of A and B is largest positive number that divides both A and B without a remainder. So in our prime factorization of 999, we end up getting 37. So if we factor out 9 from the numerator and the denominator, that's what we're going to have in common. So 9 times 11 gives us 99. 9 times 111 gives us 999. Okay, so then we cancel out the common factor. It's just the 9. Okay, we cancel out the 9 or draw a line through it, and the only thing we have left is 11 over 111. And that's the correct answer. Well, what if we have a fraction with a whole number? Let's say we have 5 and 3/5. Well, then you ask yourself, can we reduce this? Let's look at it. 5 times 3/5 equals 3. And let's look at the steps. Convert the fraction 5 to 5 over 1. So remember, anytime you have a whole number, you just place it over 1 and you immediately have a fraction conversion. So then we refine. We always multiply numerator, numerator, denominator, denominator. So we have 5 times 3 is 15. 1 times 5 is 5, because when you multiply fractions, you're using A over B times C over D equals A times C over B times D. Then we refine this. We have 315 divided by 5. Or we can cancel the common factor before we even divide. And so we would draw a line through the 5 and leave the 2, and leave the 3. Sorry. And then when there's nothing in the denominator, there's a 1 there. And that's 3 over 1, which is 3. Thank you.